Hello, this is Dr. Sturms from Geosystems, and this is some extra guidance if you need help finishing the upside down cup demonstration. So here's the assignment. You can see there's a video in the assignment of Mr. Pruis helping his son understand the experiment. And let's just walk through each one, and then you can go ahead and pause this video and fill in the answers as we move along. So the first question is, what happened? And I want you to just describe what happened when you observe the video. And what happened, number one, the answer is that Mr. Pruis, Pruess, turned the cup upside down with a piece of paper on the bottom of it. And what happened is there's an air bubble inside that causes a vacuum, and the card stays in place. The water does not fall out of the cup. And that's the answer to number one. If we move on, here's a diagram that you see with the blue arrows and the red arrows. Number two, what force does the blue arrows represent? And the blue arrows both represent air pressure, both from inside and outside. And what force does the red arrow represent? You might think that's the weight of the water, or otherwise known as gravity. And that's the answer to number two. You can pause this video and answer number two. Number three, the question number three is, when you first turn the cup upside down, the air pressure is equal all around, but the air pressure inside the cup decreases. And you can see that the air pressure arrow, force arrow inside, is actually smaller than the one pointing up toward the paper. So why? Why does the air pressure go down inside that cup? And that's what Mr. Pruis in the video talks about, a vacuum forming. What happens is a little bit of water comes out seeps out of the cup, making the space here a little bit bigger, but there's the same amount of air in there. There hasn't been any air exchange. So that means that the air pressure goes down because the space got bigger, but the same amount of air is there. So that is why the air pressure inside the cup decreases. Number four, when the air pressure outside the cup is greater than the air pressure inside the cup, the situation that we have right here, what does the card at the bottom of the cup do? This is number four. And the answer is, this is the situation we have right here. The answer is that the card stays in place. It doesn't move. The greater air pressure outside the cup holds the card in place. Number five, once water eventually leaks out a little bit because the card gets wet or because Sean hits the edge of it, what happens to the air pressure outside the cup relative to the air pressure inside the cup? The answer to that is they equalize. Are they different or the same? They're now the same once you open up this system and equalize the pressure. Now the air pressure inside and outside are the same. If you look at number six, once the air pressure inside the cup equals the air pressure outside the cup, another force takes over. The red arrow. Do you remember what that is? That's gravity. That's right. Gravity is the answer to number six. And what happens to water once the air pressure isn't holding up the cup and isn't holding the water inside anymore? The water falls out. And that is the answer to number seven. If you can, this is optional. You do not have to do this. Do the experiment by yourself at home. You can use an index card or piece of plastic or heavy cardstock. Find a cup, put up some water in it, flip it upside down. Does it work? And here's the directions. If you can't do it, if you don't have the materials, that's fine. You won't get any points off for that. All right, I hope this was helpful. Thank you.